Hello students, in this video I will explain lead tin phase diagram. What is the symbol for lead? It is Pb, and for tin it is Sn. The phase diagram is temperature versus percentage composition. Temperature should be taken in the y-axis, okay, and then the percentage composition should be taken in the x-axis. This system do not contain the vapor phase. It consists of only solid and then the liquid phase. So we need not consider about the pressure term, and we need to follow the reduced phase rule, that is F is equal to C minus P plus 1. Okay, and in the extreme left hand side we should mark 100% lead, 0% tin, and in the extreme right hand side mark 100% tin and then 0% lead. Then you need to mark a point in the y axis at 327 degrees Celsius, which is the melting point of lead. Then you need to mark point at 232 degrees Celsius in the y-axis again in the right hand side, which is the melting point of the tin. So that means melting point of lead is greater than the melting point of the tin. After this, draw a horizontal line at 183 degrees Celsius, which is the melting point of the etetic mixture. So what is etetic mixture? Etetic mixture is a one which has got a constant temperature, which is the lowest temperature of the system. The system consists of three etetic mixture. Okay, one is at 38% lead. So what should be the tin? 62% tin. And then one at 98% lead and another at the 18% lead. So mark all these 3 points. There are 3 etetic points, E1, E2, E3. Note that the point that you are marking at 98% should be in the left hand side extremely, and lead 38% should be towards the right hand side. It should not be exactly in the middle. And 18% should of lead also towards the lead, closer to the 100% of the tin. Next you need to draw the curves. Okay, join all these points as I am showing. So the red color curve, it is representing the depression of the melting point of the lead upon addition of the tin. Okay, and the green color curve represents the melting point depression of the tin upon adding the lead. Alpha is the solid phase of lead and tin where lead dominates. Beta is the solid phase of lead and tin where tin dominates. Okay, and above the curves only the liquid melt exists. Liquid melt of the lead and tin exists in above the curve, and under the area liquid melt and the alpha phase. Under the curve of the red, liquid melt and the alpha phase exist. Under the green color curve, liquid melt and a beta phase exist. Now let us calculate the degrees of freedom. Degrees of freedom, it follows reduced phase rule, that is F is equal to C minus P plus 1. Let us mark all the curves now. So what is the red color curve? Melting point depression curve of the lead. And green color curve is melting point depression curve of the tin. Because along this curve, the melting point of the tin decreases upon adding the lead. Okay. So the degrees of freedom, in the area above the curve. Only one phase exists, that is liquid melt alone exists, right? So P is equal to 1. And the number of component is equal to 2 because lead and tin is existing. So number of component is equal to 2. So 2 minus 1 plus 1. So F is equal to 2. You should note one thing, that in this system wherever one phase exists, F will be equal to 2. Wherever two phases existing, F will be equal to 1. Okay. So this is the phase diagram for the lead tin system. Mark the melting point of the lead as A and melting point of the tin as B, and all the eutectic points as E1, E2, E3. Thank you for watching. Hope you all understood, guys. Test link is given in the description box. Please attend and test yourself.